Today's date is the 30th of March 2026. Time now is 11 to 4 p.m. and the official visit is going. These are close questions to me. Close questions to me. Let me go into the camera. Let us here. What is the relationship between the mosaic and the electromagnetic? Um, uh, Basically, on the quadratic tape for its linear, single flows and only sequence of by seconds. Imagine using 2D or high dimension structure. Yes, it is a new replacement of a tape model. Extension of it, or does the additional recording or does the tape require? Okay, the mosaic implies, okay, the quadratic tape is linear. Signal flows along the sequential reverse circuits. The mosaic implies a two-dimensional high high dimensional tile structure. Yes, it is the mosaic model a replacement for the tape model? No. Basically, it is not a replacement. It's basically for the tape model to be no. Basically, it's not. Firstly, it's not a three-dimensional model because basically a magnetic system. So if you have magnets that have poles, north and south, east and west, and you're gonna have the rotation of the poles based on the lateral displacement of the system. Example, you're gonna have you're gonna have position, a polar rotation left or right, counterclockwise or clockwise. The orientation of the magnetic pole has a regional space. That regional space is mapped to a quadratic tape, not a chordic tape. Quadratic surface, quadratic tape, and that's it. Basically, is what accumulates information over time. Basically, it's a Turing machine, but as a tape. Same thing with a Turing machine and a tape. You have a Turing machine, which is like a computer that you have a magnetic, you have a Turing machine, you have a quadratic, you have a quadratic magnetic memory tape. And tape is quadratic because it's magnetic. And the tape has a kind of machine, the same machine can compute. If basically any computation you can do on the tape, you can compute an electric tape, which is the Turing machine. You have a magnetic equivalent of the system. Yep, that's it. So you have two types of tape. You have electric tape and magnetic tape, which are two types of separate tape. Now, using them, by using them, but switching different ways, working different ways. But different principles, electric tape and magnetic tape. What is fundamental unit of tau? Is the mosaic memory model a replacement for the tape model or such of it? No, the mosaic just means color coded. So the mosaic just means color code the information as you perceive it, as you stand, as you compute, so you can know what's going on with the computation. Whether you do negative rotation, or one negative or two negative rotation, this is an axis you do X, Y, Z. You have a lateral rotation. Think of two magnets polarized facing each other. And two magnet, you're gonna have magnets, you're gonna have each one of that. So if you wanna magnet, you're gonna rotate counterclockwise. So have a negative to have a north pole face the west and the south pole face the south. And you can have double magnets, basically negative one magnet and negative on the magnets. Even one's negative, you're gonna have the two magnets face north face the west side. That means you have attraction between repulsion between the two south poles. And the two south poles, because they have repel, you can compute repel minus minus, and minus minus basically repel. You see, Same for all the configuration of systems. So if you have a pole of north, south, south, basically, south, the north is facing the south, and we have subtraction, two sides facing each other. You can have two men facing each other. We have two men gonna face each other. South facing each other. You're gonna have two souths. You can have an attract. You can have a tract. That's wrong. So if the two north poles are facing west, that means you're gonna have an attract. You get north on one side and south on the other side. You have an attraction. You're gonna have an attraction instead of. You're gonna have a repulsion. You're gonna have a repulsion. You're gonna have double. Because you have double the magnet force into one dimension. You're gonna have more stronger magnet. You're gonna have a bigger magnet, and that is gonna dictate the kind of vector force of the space of a system. Because it's really magnetic. So you get a bigger magnet and can do this one thing. What is fundamental velocity is the most you're gonna have color coordinates. You're gonna have minus minus, plus minus, minus minus, plus. You're gonna have minus minus, minus plus, plus minus, and minus minus, and plus plus. More minus minus, plus plus, plus plus, based on the kind of relationship. And so using magnets to compute the state of state between 0 and 1. Zero and 1. So you're gonna have a string of you get these it's listen and analyze that takes the magnetized library, the library is the abandoned article of 0 and 1. And use a magnetism to dictate what is based to run on the computer based on how it's observed the state. What's the fundamental tau unit in the okay? Fundamental tau unit. In a emergency announcement of tau compound. Oh, a unit is basically you can have a 2 to 1 unit mapping. So you can have basically based on the rotation of the magnet, you're gonna have double the force double the force, double the force of the magnet or the pull force or the repel force -2 of repel to 1 of the strength. Those are positive 1, -1, positive 2, -2, or -2. And any one of them usually gonna be force of the magnet, the power of the magnet. The power doesn't take the force. You get a power and get a force. So the force is the other one. So you're gonna have force mapping. Also, you get a power to force ratio, and there'll be a lateral displacement of the system at scale. And that will dictate what you can compute on. Basically, compute things at a scale and position for both sides based on the rotation magnet. What's the schema? Do you know what that means? The correct model of a fluid for addressing a magnetic field, a magnetic attraction is direct to address a collision. How do you try? Oh yes, basically the Hamming man distance, the Hamming distance of the metropolitan inner network is a big sigma. You get a wireless wild inner network. So if you have a Hamming WAN, that's a wild area network, and the system has to, this is more of this is really more of a dome like a city structure, but that's basically a city. They can use they can link artifacts and runtime and make sure it's cohesive. But usually for a local group, a local scale of a drone delivery system, or anything that's magnetic environment using the system to use magnetic compile time a runtime, magnetic runtime. So how the drift cases okay. In a linear tape model, one dimensional, I want to know the drift negative configuration. Basically, take an electric tape and flip around. Basically, if you get a magnetic, and let's do the Turing machine again. So this is partial definition. In a linear tape model, drift was one dimension, and most of the is partial definition of a tile. I want to know how the basically. The linear tape drift is one dimension, yeah. So in emergency of drift becomes partial. That must mean, no, does it? No, it doesn't, 'cause it's magnetic. Uh, no, because yeah, because you go here and now, there and there, whenever, but you're gonna have, moving on drift is defined as dt, dt drift of t given v minus a vector v t minus ct, where vt is the vector of CT is the current point. And the drift is usually defined as if anything that's moving away from you. So drift from this means I'm moving away from you. So this is where you're gonna lose power or surge, the power to the ratio vacuum of the system. So what's the the Mosaic equivalent of a system. Basically, you can have the drift be drift of 90 degrees would be basically you can look at the same distribution of memory. You know what I'm saying? Drift is be moving away, moving static, and moving away, moving towards you. Somebody can move away, somebody can move away at the right angle, and move at a 45 degrees angle. What is the mosaic equivalent of live.am and live.sam? So basically, the live it's a color coded memory, and the coded memory can be basically because I have a program at runtime that executes the mental library. The mosaic system can be just basically it's just color coded. It's just basically if the tape is modeled for in second seconds, share was no, you don't need an extension. You don't need an extension. You don't need an extension. Libdor is not the mosaic equivalence is not equivalent. No equivalent there. So there's nothing there to do for equivalence for mosaic system. Just remember that from memory stuff. Remember if the system is already colored, the memory is really loaded. You don't need to cheat in the output. And any kind of arbitrary code can run and runtime can compile and then run itself. Basically, it can self lab in the real world. But basically, you're gonna have a supplement challenge. So that's what I'm saying. So you're gonna have that kind of system. So how does in a quadratic system, really, quadratic probing system? You see that kind of system, you're gonna have a compile time and a run time, and there are two different ways to do it. So there are compile time is like you compile the code, but you don't run the code. And run time is magnetic version. But if you think of a lattice and you change the lattice rotation, orientation. You define the fan. You're now in computing on lattice, and that is basically what's happening with the magnetic system. Basically, we loaded and it's now running. Because it's just shifted its poles. It just shifted its poles. Does the model allow different addition to yes? Look at the boundary versus tab, and then tab station share an edge node. Because they are bilateral. Just think that's what you do.